Welcome back to TechNation, the ultimate destination for all things tech. Today, we embark on a mind-bending journey as we delve into one of the most mysterious and intriguing phenomena in the history of space exploration, the Pioneer Anomaly. For decades, space probes like the Pioneer spacecraft have been sent out into the depths of our solar system, providing us with invaluable data and pushing the boundaries of human knowledge. But something strange happened along the way. A subtle yet persistent force seemed to be acting upon these robotic pioneers, causing them to deviate from their predicted paths. Scientists were baffled. The laws of physics couldn't fully explain this anomaly. Speculations and theories ran wild, sparking intense debates within the scientific community. Was it the result of a gravitational anomaly, an unknown force from deep space, or perhaps even a flaw in our understanding of the cosmos? Around 3 decades ago, NASA researchers observed an unusual occurrence in the trajectory of 2 spacecraft called Pioneer 10 and Pioneer 11. These spacecrafts appeared to deviate slightly from their intended course, seemingly influenced by an enigmatic and unidentified force. In 1998, the wider scientific community became aware of this deviation, referred to as the Pioneer Anomaly, and embarked on an extensive investigation characterized by relentless and incredibly detailed scrutiny. This pursuit elevated the anomaly to a revered status in the realm of physics, comparable to that of a cult following. However, at present, this cherished cosmic enigma may be nearing its resolution, marking the potential conclusion to nearly 1,000 scholarly papers, numerous international conferences, and even entire scientific careers dedicated to unraveling its secrets. Back in the spring of 1972, NASA launched Pioneer 10, followed by Pioneer 11 a year later. These spacecraft were tasked with a joint mission to gather information about the asteroid belt, Jupiter, and in the case of Pioneer 11, Saturn and its moons. As the probes swiftly traversed past these celestial bodies, they collected data on previously unknown properties of their atmospheres and surfaces. Additionally, they captured unprecedented close-up photographs of Jupiter's red spot and Saturn's rings. Following the completion of their flyby missions in the mid-1970s, the pioneers continued their journey. Carrying identical plaques depicting a man and a woman, the atomic transition of hydrogen, and the location of our planet within the galaxy as a message to potential extraterrestrial beings, these probes became the first human-made objects to venture beyond the solar system, venturing into the unimaginably frigid and dark expanse of interstellar space. The scientists at the Jet Propulsion Laboratory, JPL, diligently continued their Doppler tracking of the Pioneer spacecraft as they ventured deeper into the vastness of space. By maintaining a continuous flow of radio transmissions to and from the Pioneers, the scientists meticulously recorded the velocity of each spacecraft at every point along its trajectory. Leading the analysis of the Doppler ranging data was an astronomer named John Anderson and his team. Their primary objective was to utilize this data to investigate subtle gravitational effects in the outer regions of the solar system, where the dominant influences of the Sun and larger planets were significantly diminished. One intriguing possibility was that the pioneers might exhibit oscillations in resonance with low-frequency gravity waves. To successfully detect and comprehend these peculiarities in the spacecraft's motion, the scientists faced the daunting task of precisely predicting their expected behavior. This necessitated the development of an algorithm of immense complexity. The predicted Doppler shift encompassed various contributing factors, including the deceleration experienced by the pioneers as they battled against the gravitational forces of the Sun, planets, moons, asteroid belts, and comet clouds, entities whose positions and gravitational fields were in constant flux. Other factors included the diminishing effect of solar radiation pressure on the spacecraft as they moved farther away and experienced changing angles, the increasing delay time between the transmission and reception of radio waves as the spacecraft receded, the gravitational drag exerted on the radio waves by the Sun, and the additional frequency shift caused by the Earth's rotation. This comprehensive list of cosmic influences was skillfully synthesized by Anderson into a single algorithm. However, unfortunately, the algorithm did not yield the expected results. In 1980, Anderson noticed a slight discrepancy between the anticipated Doppler shifts based on his algorithm and the actual measured shifts of the radio signals emitted by the spacecraft. The projected and observed motions did not align perfectly. As the spacecraft journeyed outward, opposing the gravitational pull of the Sun and planets, they naturally decelerated. Yet, the issue was that they decelerated more than anticipated. Each year, both spacecraft fell a few hundred miles behind their projected paths according to the algorithm. While seemingly insignificant in the vast expanse of space travel, this deviation was not trivial. The persistent additional acceleration amounted to 8.74 x 10 to 10 meters per square second directed toward the Sun, a factor 10 billion times smaller than the acceleration due to gravity, but undeniably present. Anderson's initial response was to consider the possibility that his algorithm might have overlooked a minute factor influencing the spacecraft's motion. Perhaps a tiny influence had been excluded from the mathematical calculations. After several years of contemplation and discussions, Anderson and his team arrived at the conclusion that the anomalous acceleration could be attributed to outgassing, the leakage of fuel from the thrusters, exerting a recoil force on the spacecraft as it dripped. Since the spacecraft were now traversing interstellar space without propulsion, the scientists believed that the fuel leakage would eventually cease, leading to the disappearance of the effect. However, perplexingly, this was not the case. Over the following decade, the spacecraft accumulated billions of miles traveled, but still thousands of miles less than expected. In 1994, Anderson unexpectedly received an email from Michael Martin Nieto, a cosmologist at Los Alamos National Laboratory near Santa Fe, New Mexico. Nieto had recently developed an interest in alternatives to Newton's inverse square law of gravity, such as a new theory known as MOND, modified Newtonian dynamics. Curious about NASA's certainty regarding the strength of gravity based on their observations of spacecraft motion, Nieto reached out to Anderson. In response, Anderson revealed that gravity seemed to be behaving anomalously for the pioneers. When Nieto came across the exact value of the small, anomalous acceleration experienced by Pioneer 10 and 11, he was taken aback. In his own words, "My office had a hard floor and my computer chair had wheels, so when I arched my back in a wah reaction, the chair started rolling." There was a remarkable cosmic coincidence at play. Nieto quickly realized that the value of the Pioneer anomaly closely matched the cosmic acceleration, which is the product of the speed of light, c, multiplied by the Hubble constant, h. This suggested that the root cause of the anomaly resided within the fundamental principles of physics. Right at that moment, Nieto immediately joined forces with Anderson at JPL, initiating a significant investigation into the Pioneer anomaly and dedicating most of his efforts to its study ever since. When asked why, he recently expressed, "The Pioneer anomaly could potentially be the initial evidence of gravity deviating from its inverse square dependence. It has the potential to be groundbreaking." Shortly thereafter, Slava Tereshev, who had recently arrived at JPL from Moscow, joined forces with Anderson and Nieto. Together, along with 3 others, they embarked on an extensive analysis of all the available Doppler data from the Pioneer spacecraft. Simultaneously, they examined data from other missions and tentatively discovered anomalies in the trajectories of Ulysses and Galileo as well. Only the Pioneers, Ulysses, and Galileo drift freely in space. Other NASA spacecraft are stabilized in 3 axes, employing gas thrusts to maintain their intended paths and eliminate minor divergences in motion. The JPL scientists observed that all 4 non-3-axis stabilized crafts appeared to deviate. In 1998, they shared their findings with the world through a thought-provoking article in Physical Review Letters, which opened a proverbial can of worms. What followed was a state of chaos. Tereshev explained, "1998 was a fascinating year because just as we made the Pioneer anomaly known, the discovery of dark energy occurred. Suddenly, we realized that the universe is accelerating due to dark energy, and people became ecstatic, suggesting that if we modify gravity, all of these anomalies would vanish. It seemed as if Einstein and Newton's theories would be overthrown. Historically, minor irregularities in celestial motion have led to significant revolutions in physics. One such example was the renowned anomalous precession of Mercury's perihelion, which played a crucial role in substantiating Einstein's theory of general relativity in 1915. In 1998, drawing comparisons to this historical precedent undoubtedly elevated the prominence of the Pioneer anomaly, along with various outsider theories attempting to explain it. Among these theories is the aforementioned MOND, which proposes that gravity deviates slightly from the inverse square law at vast distances from massive bodies. Since 1998, hundreds of physics papers have been published, asserting that MOND provides a plausible explanation for the Pioneer Anomaly. In conclusion, the Pioneer Anomaly has captivated the attention of scientists and researchers for decades. What began as a subtle deviation in the motion of the Pioneer spacecraft evolved into a perplexing cosmic mystery, challenging the fundamental understanding of gravity and prompting alternative theories to emerge. The tireless efforts of individuals like John Anderson, Michael Martin Nieto, and Slava Tereshev, along with their teams, have brought the anomaly to the forefront of scientific inquiry. While numerous hypotheses and investigations have been conducted, the resolution to the Pioneer Anomaly remains elusive. However, the ongoing research and analysis continue to shed light on the intricacies of celestial motion and the nature of gravity itself. Whether it leads to a revision of our current understanding of the universe or the confirmation of established principles, the journey to uncover the truth behind this enigma serves as a testament to human curiosity and the relentless pursuit of knowledge. As the scientific community eagerly awaits the forthcoming publication by Slava Tereshev and Viktor Toth, the culmination of their comprehensive analysis, we stand on the cusp of a potential breakthrough. The resolution of the Pioneer Anomaly could have far-reaching implications, providing insights into the nature of gravity and paving the way for further exploration of the cosmos. In the vast expanse of space and the boundless depths of human curiosity, the Pioneer Anomaly stands as a reminder of the mysteries that still await our discovery. It represents the spirit of scientific inquiry, driving us to question, investigate, and challenge our understanding of the universe. The unraveling of this beloved cosmic mystery may mark a milestone in our quest for knowledge, while inspiring future generations to explore the frontiers of science and unravel the secrets that lie beyond. Don't forget to like, share, and subscribe.